What I want to do, hopefully in this session, is show you the value that you can get by upgrading to 2012, and then also how actually there's a fairly straightforward migration path or upgrade path from 2007 to 2012, and I'll show you how we go about that. So I'm going to show you the key focus areas for the Ops Manager product and talk about the new hierarchy. The challenges that I will mention during this, I'm sure all of you are experiencing. So the hierarchy's changed with 2012, and it's going to resolve a number of these challenges that you currently face. Talk about extending visibility, not only with the new product, but just briefly touch on where Microsoft have come from a maturity perspective with the previous releases. Show you some of the new dashboarding and how the web and thick console have come a lot closer together now. And then we're going to talk about upgrading from Ops Manager 2007 R2 to 2012. So now we want to talk about monitoring our solution with Ops Manager. Firstly, it's an enterprise system service and network monitoring tool. So the three key focus areas, firstly, was to reduce the total cost of ownership. And Microsoft did that by simplifying the topology that you needed to deploy to support your environment. And as a result, it actually made the solution more reliable because it became highly available out of the box. And it gives us this monitoring consistency now because we can extend our monitoring reach to other devices and other products and platforms that we might have otherwise required additional tools to monitor with. Gives us a holistic view, that single pane of glass that everybody has been asking for when it comes to monitoring. And that's also through some new capabilities with regards to monitoring devices that we can target. But we can really extend the solution using the Quest Management extensions. And many of you where we've worked with in the past would know that this is a tool that we recommend to be able to extend the reach to other storage platforms that we might not have been able to monitor or other applications. And there's these new focus on visualizations, being able to logically present information to you. A lot more power with the new dashboarding capabilities. And also, we always recommend this Live Maps product, which is from a partner of ours called StarVision, because it gives us a lot more control and flexibility over data presentation. So let's have a look at a typical SCOM 2007 R2 topology. So this is, say, a management group. We've got clustered root management server, a couple of management servers, large number of agents feeding data up into those management servers, and a couple of databases in the back end. If we focus on the root management server, there's a couple of features or services that the root management server had to provide for the management group. Firstly, all of the consoles connected through the root management server, and that's because there were services presented out from the RMS that provided access to the data in the database. It delivered all the alerts, so all your SMS, all your email notifications were sent from the root management server. It was a connector to other management systems, provided health aggregation for all your distributed application models, and it was the role that the server that actually calculated all your group membership. So if you had a lot of groups in your management group, all the membership calculation had to run on the root management server. Plus it might be monitoring as well. So it's got a lot of things that it has to do. So the end result of that was, it was a performance and it was a scalability bottleneck. I guarantee anybody that's got Ops Manager deployed in their environment at some point in time would have experienced console lag. And it's a result of the amount of work that the root management server has to do. So the way we fixed that was we threw as much hardware at that as we could. Give that role as much processing and memory that we really could, and that was our way to work around it. And if you wanted high availability, we would either rely on the high availability provided by your virtualization platform, or we would deploy a cluster. And with that meant shared storage, high-end hardware, plus somebody to support that cluster as well, should something go wrong. So in 2012, the root management server role has been removed from the management group now. So what that meant was it gave us high availability out of the box because we just deploy multiple management servers, and those roles that were provided by the root management server in 2007 are now just balanced across all the management servers that are deployed within the management group. So that meant we could run it on more commodity type hardware if we were in a physical solution, or just virtualization, but we didn't need to have such high-end VMs. So in 2007, if we lost a management server, agents would fail across to another management server. But the workflows that were running on that agent at the point in time when it failed would be lost, and they'd have to be started again. Now the workloads can actually be failed across as well. How many people using Ops Manager to monitor network devices as well? I know a couple of you are. So the challenge with that in 2007 was you would create a discovery, you'd find network devices deployed in your environment, and you would tell a particular management server to start monitoring those devices. If you lost that management server, nothing would be monitoring those devices. You'd have to manually move them across or have a script that performed the migration for you. Now in 2012, we use these things called resource pools. So a resource pool is just a grouping of management servers. So what we do there is when we target monitoring of particular network devices, we say it's going to be monitored by this resource pool instead of this management server. So if we lose a management server in the resource pool, other members of that resource pool will just pick up the monitoring responsibility. So it makes it a lot easier, gives us that high availability. We don't have to manually move network devices anymore. And I want to talk quickly about how we've extended visibility. Firstly, in SCOM 2007, distributed application models were introduced into the product. And that was a way that we could group components together for monitoring. So we might have a web application and we know it has an IIS website, a particular database, and maybe a number of services that we need to monitor. We can group that together into a distributed application model so that if one of them became unhealthy, we could understand the true impact that that has on the services we provide. Microsoft also added synthetic transactions, so we could record transactions using our web browser and replay them over time to calculate health and performance as well. In R2, Microsoft introduced cross-platform monitoring, so we could then monitor things like Solaris, Linux, Unix, HP UX, AIX systems via an agent within the Ops Manager solution. And then in 2012, we now have native network monitoring, .NET and Java application monitoring as well, natively within the product. And we can take that even further using the SARvision Live Maps, and we're going to go into some detail about that, as well as the Quest Management extensions. So network monitoring, there's 4 key areas that you need to think about when we talk about network monitoring. We need to be able to discover the devices. We need to be able to monitor them. We need to be able to actually present that information out, visualize how it all fits together and what the performance and the health looks like, and then run reports so we can do some trending. So with regards to discovery, we now have discovery rules. So we create these discovery rules and we run them on a schedule. So rather than with 2007 where we would kick off a discovery, we would find the devices, select the one we want. It's just a one-time execution. Now we create a discovery rule and we run it on a schedule so that as new devices are added to our network, if they conform to our monitoring standards, like they have the correct SNMP community string defined, we'll just automatically monitor them or automatically discover them and automatically start monitoring them. And there's multi-protocol support. Not only do we support V1 and V2C now, it supports V3 as well, but not every device is going to support SNMP, so you can now use ICMP to target, monitor devices to make sure they're online. You can monitor multi-vendors, so over 80 hardware vendors, and you get your availability and your performance details about that device. You can present that data out through dashboards, and you get your diagram views, your alert, your state, your performance views, things that you used to seeing with your normal Windows-based devices. And of course, we get a number of native reports available that we can run out of the reporting workspace. So when it comes to network devices, what is monitored? So out of the box, ports and interfaces. So up and down status, but also it's intelligent enough to detect whether a port is just administratively shut down. So it's not going to monitor it if it's administratively shut down, but it also checks to see what devices are connected to the port. So if a network device is connected to a port, then it's going to monitor that port. But if a client's connected to a port, it's not going to monitor that by default because I don't want an alert raised every time someone takes their laptop home. But you can monitor it. So if we've got servers connected to ports or important PCs connected to ports, we can monitor those ports simply by adding the port to a group within Ops Manager. We monitor the volumes of inbound and outbound traffic, percentage utilization, the drop and broadcast rates as well. Processor and memory utilization are monitored. We also monitor additional counters out of the product if you're using Cisco-based devices. And there's 4 key dashboards, and I'm going to show you that in the first demo. But we've got a network summary dashboard that gives you at a very high level the health of devices. So it's going to show you the top 25 devices that have performance issues, the top 25 interfaces that have high utilization, alerts, things like that you can quickly go to a dashboard to hopefully help you proactively prevent a failure. Network node dashboard gives us specifics about each of the devices. Same for the interface, for specifics for a particular interface. And the vicinity is where Scott talked about Microsoft have licensed a component of EMC Smart. So it's the network discovery component. And what it'll do is it'll map out your network physically and show you how it's all connected together, which devices are connected to which ports, which servers are connected to which ports. And you can select a device and say, I want to see all the devices so many hops away, and it'll just build us out that diagram. And I'll show you that in the demo too. So let's take a look at the network monitoring demo. So the first thing we're going to do is create a discovery rule. So I'm in the discovery rules view within the administration workspace. And over on the right-hand side in the tasks pane, you can see we've got a task there to discover network devices. I'm going to give it a name. We'll select the management server that we want that discovery rule to run on. Each management server can only ever have one discovery rule targeted to run on that management server. Select the resource pool that I want to use to monitor the devices that we discover. I'm going to select the all management servers resource pool because I don't have a custom one developed in this instance. And then we're going to click next. So now we've got two discovery methods. We've got explicit and recursive. Recursive means that we just target a single device and let it go and find everything on the network. Explicit, we put in a specific range. We're going to select a community string. In 2012, you have to create a community string as a run as account so that it encrypts the SNMP community string. So I'll just select one that I've already got pre-created. Select the device that I want to target. So in this environment, I'm just going to select a single router that I've got in my lab, and I'm going to tell it to go and find everything. I'm going to let it use ICMP or SNMP, so it'll try both. The SNMP version number, and then also the default community string that I want to use. We'll click OK. So now I've got a single device. I can use include and exclude filters, so I could say, even though that device might find a lot more devices, only include things within this range. Or we could specifically exclude a particular range of devices. And then we can set the schedule, how often we want this discovery rule to rerun. So I only want it to run once because my wife rarely lets me buy more Cisco kit for home. So I'm going to select run it manually. And we'll click create. So now that's created me the discovery rule. You can see that at the moment the status is idle and the last discovered column is blank because that rule has never run. So I'm going to kick that off. We'll click run. The task is just saying that it's all gone and requested that the discovery rule run, and that was successful. So it's gone and started the discovery process now. So we'll leave that run because that'll take a little bit of time to crawl the network and find everything. And I'll go and show you what we actually get using network monitoring. So we come into the monitoring workspace and you see the network monitoring folder. It's got your active alerts, a number of state-based views, and a network summary dashboard. So when I select network devices, you can see there's 3 Cisco devices. We've got a couple of routers and a switch in there, and they're all healthy. It's got some details about it. And then we can go into the different views that are based on the class type. So we've got routers and switches and VLANs. It's going to show me all of those as well, and their state. So now we'll have a look at the network summary dashboard. This is a really good view that you could go into, in the morning or a couple of times during the day to just quickly check if there's any devices that are all of a sudden got some issues. So now I'm going to select a device, and we'll select one of the routers, and we'll actually go and load up the vicinity dashboard. And I'll show you that view that dynamically builds out the physical connections within our network. You can see we can zoom in and out. It's a little hard to read, but there is a hops option up the top there. So based on the device that I've selected, it's going to show me other devices that are within one hop of that selected device. So I'll change that to 2. And what we'll see is we'll get another device automatically added into the diagram. As I select the devices, the instance details change. So inventory that we've collected from those devices updates automatically in the console. And you can see the links between the devices. They're green at the moment because Ops Manager has detected that they're healthy. It shows me which port they're connected on, so you can see the device, the port. So 252 is on Ethernet 0, 253 is connected on Gigabit 22. Now I've selected the switch and I've loaded up the node dashboard. So it's giving me all the particulars for that particular switch. Still keeps me a reduced view of the vicinity dashboard, average availability, the ICMP response time, so management server pinging the device, processor utilization, and all of the ports. So I mentioned the fact that we're not monitoring all the ports by default because you don't want all of that information. But we are monitoring the devices, the ports that are connected to other network devices. So I'll select one of them, and now I'll open up the interface dashboard, and it'll give me specifics on that interface. Bits sent and received, packets sent and received, errors and discards, and then obviously all types of alerts. So while we wait still for the discovery to finish off, I'll just go and show you the diagram view that I'm sure you're used to seeing when you open up diagram view for other devices that you've got in your environment. It shows us all the inventory or the components that it knows about, which ones we're monitoring, their health state, and also ones we're not monitoring. So under healthy, you can see memory, processor, and 2 ports that we're monitoring. They're all healthy. But under not monitored, it's going to show us a number of components that we know about of this device, but we're just not monitoring at the moment. So we could create monitors for them, or even some of them we just turn the monitors on. So now I just want to go and show you the discovery rule and show you that it's finished. It's still running, and then it's finished. So you can see it's discovered 3 devices. So application performance monitoring, Scott talked about that, the battle that we have between the infrastructure guys and the developers. And it's not that we don't like to work with them, but typically when we identify performance issues with applications, it's getting access to the data that's going to help us troubleshoot it that's the problem. Our infrastructure is always screaming along. It's never our problem. We always think it's code, and the developers always think that their code is perfect and it's got to be infrastructure related. Application monitoring in 2012 is going to give you access to data so that it can help us troubleshoot these issues.
Please respond to any further alarms.
Firstly, there's 2 ways we can monitor. There's server-side and client-side perspectives. And what we're doing here is we're actually getting copies of all the requests that take place between those systems. From a server side, it's back-end. It could be requests that take place between our web front ends and our SQL servers. And we monitor them. We look inside the request to see what they're actually doing. And we define thresholds, so how long the request should actually take to complete. If they breach them, we raise an error. And we can also monitor client side, so requests that occur between the clients and our web front ends. And again, we set thresholds on them, we monitor them, and if they breach that threshold, we raise an alert. So it gives us that insight into really how our applications are performing, and it's natively built into the product. The power is in the alert context, and you can see that in the demo when I show you an application breaching some thresholds and showing us that rich detail into where it thinks the problem resides. And there's 2 tools that are also included in 2012. There's the Application Advisor, and that gives us information that we might want to provide to our management or our application owners. Things about how our app has been performing, how many requests it's had, how the servers that it's hosted on are performing as well. And the diagnostics tool is typically used by developers or the infrastructure guys to help us troubleshoot issues. Let's take a look at that demo. Back in the Ops Manager console, I'm going to come down to the application monitoring view and I'll show you the discovered .NET applications. So there's a discovery process that runs that goes and finds all of the inventory. So all of the .NET apps that are running on IIS, where servers have the agent deployed. It's not going to monitor these by default. It's just identifying them in case we want to enable monitoring. So you can see it's returned a list of them. Now I'm going to show you how easy it is, even though I've already created the monitoring rule, how easy you can create them. So you jump into your authoring workspace. You're obviously going to need permissions to get into the authoring workspace. And we'll go and create a new monitoring rule with a .NET application performance monitoring type. So I'll launch up the monitoring wizard. I'll select the .NET Application Performance monitoring type, and we'll give it a name. Now while I type that, see down the bottom here, where you're selecting your destination management pack? 2007, it would default to the default management pack, and people would even accidentally save things in the default management pack. And that was a nightmare. So anytime we wanted to change something, maybe remove a management pack where there was a reference in the default management pack, we'd have to go and manually edit the XML of the default management pack to pull that out before we could even export or pull a management pack out. Now that you have to manually select a destination management pack, hopefully we'll see that people won't use the default management pack at all anymore. So now I've clicked add, and I'm going to search for that, that list of .NET apps, that inventory that I showed you a moment ago. I'm going to select the Dinner Now application, select the environment where it's running, say production, set the threshold, how long requests should take to complete, and we can go into advanced as well, where we can set some additional parameters around how that application should perform. If I tick the client-side monitoring, it would then give me some options to define client-side settings as well, like how long requests should take to complete. But because we needed data for this demo, I'd already created one, and I'll show you the only thing I've changed on this is I've reduced the threshold from 15,000 milliseconds to 10,000 milliseconds, because I can recycle the app pool and it'll force a failure or a threshold breach greater than 10,000. So what I'm going to do now is I'm actually just going to go, before we kick off the failure, and show you when you create a monitoring rule, it adds some additional views and folders within the monitoring workspace for you. So we'll jump back across there, come down to our .NET monitoring, and you'll see the Dinner Now -production folder there. And that's created with the same name as the monitoring rule that you built. You'll see there's active alerts, state views, and some performance view as well. And the performance views just pulled .NET performance counters from that server back into the console, so we can monitor them in real time. In the active alerts view, note that there's no active alerts at the moment. So I'm going to cause a failure and we'll get an active alert. So we'll jump across to the Dinner Now server. The first thing we'll do is we'll cycle that app pool. So as everyone would know, you recycle your app pool. Next time someone accesses the web app that references that app pool, it's got to start it up again. So it's going to take a little bit longer, which will make me breach that threshold. So I'm loading Dinner Now. You'll see it's taking a little longer to load. And I'm also going to kick off a search once it eventually does load to search for some food. And it's not that it fails, it's just that it's taking a little bit of time, so it's going to breach the threshold. Put in my zip code. It's developed by a guy that works for Microsoft in the US, hence it only supports a couple of American zip codes. And we'll search. And you can still see that the search has taken a fair amount of time to run. But it has returned me a result. So let's go and have a look at the alert now that was raised. So it's a warning because it hasn't failed, but there was an issue. Because we don't want that poor performance, for our users that are potentially spending money with us. So we open up the alert, we can see that there was a threshold breach and the server that it was breached on. And there's a link in there that will take us to the application diagnostics tool. I'm going to launch that in just a sec. The product knowledge could give me some basic information about potentially why that could have occurred. But this is where the real value is when you load the application diagnostics link. So you click on that and it'll take you to the event details within the app diagnostics tool. So what you're seeing on the screen here is all the requests that took place when that threshold breach occurred. We can see how long they took to occur as well. So you can see there were SQL connections, but the search.aspx page was the one that actually breached the threshold, and it gives me some details about that. Like Scott mentioned, if it was a SQL query, it would have the query in there, and we could copy the query out and potentially go and run it in the management studio just to see if there's a way we could better optimize that query. The distributed chains here, you can see the search.aspx is the only one in there, but it might call some other files that we might need to take a look at as well. So code might exist in another ASPX page that could be causing the problem. even though this one was the one that generated the breach. We can update the counters and in real time see the performance counters for those .NET performance objects in that application diagnostics window. So now I'll show you the two tools themselves. Under the Ops Manager program group, they'll appear as new programs that you can execute. So the application diagnostics tool gives us that rich troubleshooting information. So events that have occurred for the particular applications over the specified time window. So I can define those filters on the left-hand side. You can see the dinner now dash production is the only one selected at the moment. That's because that's the only application that we're monitoring. You can see a number of the search events because they're the ones that I was just having generate alerts because I just wanted to generate a number of events. But I also had some SQL ones here. So you can see there was a SQL connection error. And that's because I had stopped the SQL service on the database backend that caused it to fail. So it's telling me now that it had a SQL-related connection issue. So the last one I want to show you is the actual Application Advisor tool, where we can create some really detailed reports to deliver to our application owners or our managers regarding services or applications that we make available to our end users. So I'm selecting the application status report, and then same thing, we can select a time range. We select an application that we want to use within the report, and then we click apply and it'll go and get all of that data together and present it out in a report for me. So you can see information about the memory and the CPU that the application was using, number of requests, the top alerts, the exceptions that have been raised for that particular application. And then also those reports. So a lot of your users will have access to the reporting workspace, so it makes sense that those reports are available through the console as well. So you can get access to them through the reporting workspace. Many of you that we have worked with would have SAR Vision Live Maps deployed in your organisation because we see so much value added by this product. So I'll really quickly touch on what it can do. Firstly, you can map out applications and present them in a format that's logical, because some of your users might be trying to troubleshoot alerts, but they don't understand the true impact it has on your environment because they don't know that this website is part of this service. So we can build out these application and network diagram views that show us exactly how that, how all of our different components that we're monitoring tie together. We can then roll that up into dashboards, as you see in the bottom right there. And that way we can present that out on a dashboard around our offices and see at a very high level how our key services are performing. We can map data center floor plans and be able to drill right into rack levels, or we can present geographical maps as well. But one of the most powerful new features with the latest version that is available for 2012 is Bing Maps integration. So now you can have a single view within Ops Manager that overlays health objects directly onto Bing Maps. So you might build a site diagram using Live Maps, and one of the values you can set there is a longitude, latitude feature or an address. And so it'll automatically then place a pin on Bing Maps. You can drill in or you can zoom out as well. So as you zoom out, it clusters all of those together. So if this is a picture of New York, so they've actually got this working for all of the McDonald's branches across, or McDonald's stores across America. So you can see when it's zoomed in like that, you can see all the individual locations, but when you zoom out, New York just becomes a single pin on the map. And then you can scroll around Bing Maps exactly like you would be used to doing within your browser. And QMX, again, many of you would be used to working with this tool, but it's a way that we can monitor devices that would otherwise have been unavailable. We use it a lot to monitor storage or applications like BlackBerry or VMware. And the way it does that is you use extensions within QMX, and they're just like management packs. They tell the product how to get access to that data. It could be via APIs, it could be command lines, it could be SNMP. But it collects that information and then inserts it into Ops Manager so that you can consume those alerts. It's agentless though. So for all your ESX hosts that we want to monitor, we don't actually have to put an agent on those devices. And if there's not an extension available for you, Quest would typically develop it for the device that you want to monitor. So two other quick products I want to touch on from these two vendors. Vital Signs. So Vital Signs is from StarVision as well, and what it will enable you to do is if you identify an issue, say a performance issue with a server or a group of servers, if you want to monitor those real-time performance counters in Ops Manager, you're only getting those performance collection intervals of typically every 5 minutes. But you might want more details than that. So you would normally RDP to that server, open up Perfmon, select the counters you want, and you might have to do that across multiple servers. It consumes a little bit of time and effort. With Vital Signs, it's a single console that enables you to get access to all of that data from one console without deploying an agent to those devices. But it'll also connect into Ops Manager, so it'll show you performance details over the last whatever time window, maybe 7 days that you've selected, and then it'll show you in real time your proper performance collections of every 15 seconds. And it'll also show you on that timeline anytime events have occurred for that particular server. And there's also some detailed troubleshooting assistance for Hyper-V, Exchange and SQL. Excuse me. And also, we talked about application monitoring. Quest enables us to take that one step further. So there's a number of modules available for the Foglight product. We can do .NET, Java, Oracle, end user monitoring, network monitoring. So they've got some additional capability. It'll collect that information and insert that into Ops Manager as well. And I encourage you to have a chat to the guys from Quest if you want some more information about that. Now the viewing is a lot more consistent, be it the thick console, the web console, or now being able to even publish that information out using SharePoint, using the dashboard viewer web part, that we can snap into your existing SharePoint 2010 implementations. How many people have the service level dashboards deployed in their environment? So there's a few challenges with the service level dashboards in 2007. Firstly, it's published out via SharePoint. So if you want that information available in your Ops Manager console, you'd have to use a web page view. And the web page view didn't scale with the SharePoint, with the service level dashboard. So you'd have scroll bars. It was typically a little bit ugly. It's easier to use now with 2012. So it's natively built into the console. But if you want to publish it out, you publish it out using the dashboard viewer web part. When we're building dashboards, we use widgets now. So in 2007, when you're building dashboards, all it gave you the ability to do was build multi-cell dashboards and select other views that are already built in your environment and snap them into the one view. Now using widgets, we can actually build these dashboards on the fly. So there's 3 widgets available at the moment, a performance, a state, and an alert-based widget. But there's plenty more to come. Microsoft are committed to continuing to develop them, and they'll be available from third parties as well, so you can import them using management packs. And there'll be a number of partner dashboards. So the product teams are working on these dashboards to provide all of this data into single views for you. You know, one for Exchange, one for SQL, that brings all of that data into a single console, make it easier for you to assist you in troubleshooting. Now I want to show you the dashboards demo. So I'm going to show you in this demo how easy it is to create these dashboards. But firstly, to do that, I'm going to create a group. Now the reason I'm creating a group is because unlike 2007, I can create a group with a number of members and target the view to show me the health state of that group, and it'll actually enumerate the members. Not with 2007, it would just show me the group state, but that didn't mean anything because I don't understand exactly what the health state of the group even means. I want to see what the child objects are. So I'm selecting 2 servers that we've got, the management server first of all, and the SQL server. So I've added them into my group, and we'll create that. We'll look for the SCOM group just to make sure that it's there. And there we have it, so SCOM servers. So across the monitoring workspace, I'll create a 3-cell view or 3-cell dashboard. Create it under the existing folder that I've got. I want a grid layout, I'll give it a name. Three cell, select how I want it presented, and we'll go ahead and create that. So the next bit I want to do is I'm just going to go ahead and add the widgets to those views. So you can see now we've got click to add widget instead of with 2007 it would say click to add view, and we'd have to go and select a view that had already been created. So the first one I want is a state widget. I give it a name. Select the objects that I want included in that. And because I created that group before, I can just select the group and it'll select all of the child objects of that group or all of the members of that group. Okay. Select, I might want to only show particular health states, but I want to show everything, so I just leave it deselected. How I want it to be sorted, and I want this one sorted by the health state. Now I've created that view. So that cell has been populated with the properties I specify during that widget selection. Now I'll do another one, and this time I'm going to do a performance-based view, and I'm going to select a couple of performance counter objects. So your processor utilization and your memory utilization. We'll select the group. And we'll select those performance counter objects. So memory, and then we'll select processor. Select the time range. How much data do I want to show in that particular view? It might only be a couple of hours. I've selected 24 hours. The objects that I want to appear in the legend as well. Now that one's created. So the final view I want to do is I'm going to use the alert-based widget so I can get all of the active alerts for that group of servers as well. Select the group. Select the criteria. I only want new alerts to be shown. I don't want closed ones because closed ones still reside in the operational database and I don't want that presented. I'm going to say I want it sorted by severity, so the highest or the most severe alerts will appear at the top. And then we'll create that. So now I've built a dashboard that's customized to my requirements, in a couple of minutes. I'm just going to quickly show you that that view is consistent even when we port that across to the web console. So that loads up. Now the last one I want to show you is I want to actually show you presenting that out using the dashboard viewer web part. So making that data available in SharePoint to our other users, because you might have high-level information that you might want to make available as part of your intranet site. There is a web part now that'll help us do that. So I'm just creating a blank document library and I'm going to make it a web part page so that I can add that web part to it and then go and configure it to get the information that I want. So the site that I'm using is just a brand new base install SharePoint Foundation 2010. So I've created myself just a document library so I can add that web part in. I'm going to edit it. Close down that first document list and then add a new web part. So I'm selecting from the Microsoft System Center folder and the Operations Manager Dashboard Viewer web part. So you can see that's added in. Now I need to configure it. So firstly I set the web console connection. And I need to put in the dashboard link. So I'm going to go and select the address from the address bar of the portal from the web console that contains the dashboard that I want. So I've just simply copied it out of the address bar and I paste it in to the dashboard link. Give it a title. Click OK, then we'll exit out of the editing. And we'll just launch that up to show you that that works. So now we can not only make these dashboards available, but we can publish them out really easily to our end users. So when I click on that, it goes and loads up the dashboard, the System Center web console gets access to the dashboard, but strips off all the other things like the activities or the ability to go through the navigation pane to find other health information. So how do we get there? Firstly, you can upgrade at your own pace. Because it's your monitoring solution, Microsoft realised that people aren't going to be able to just take their monitoring solution offline, so you can upgrade it at your own pace. The 2012 includes an upgrade management pack, so you import it into your 2007 environment. It'll run a discovery against what you've got deployed, and it'll show you in a particular order how they need to be upgraded. So it'll set them all to a warning state at first, but it'll monitor the progress. So as you upgrade things, it'll change them to healthy. So the basic process is everything has to be 64-bit. All of the management servers, the root management server, have to be 64-bit. So you have to upgrade them first. Then you upgrade the management servers to 2012. Doesn't matter which ones, you just pick management servers and do them one at a time. Upgrade all the agents. So as you upgrade a management server, you'll need to upgrade the agents that are reporting health to that management server. Upgrade your databases because the schema changes, so you need to run an installation upgrade over the databases. And finally, you work out what you're going to do with your root management server. Are you just going to delete it, or are you actually going to run the upgrade process on it, which is essentially just a downgrade to a management server, but it'll take it to 2010.